Hey guys, all right, we have made it to lesson 4 this week. So the plan is, you guys, I'm going to post this probably tonight, but you'll be doing it tomorrow, Thursday. And then on Friday is your day to go back and rewatch any videos you need to, keep working on homework. I know some of you guys are emailing me questions about homework and stuff, and man, I feel bad I can't get back to everyone. I've got 2 kids with COVID. One of them's doing pretty good, but the other's pretty sick. So just surviving here. But there is a Saturday in our future with donuts and maybe a tutorial or something. So I'll make sure and take care of you guys, and things that you don't get done homework wise. We'll definitely spend some time maybe after school next week or something like that. But I'm still congested and stuff like that, but I'm doing pretty good and cleared to come back on Monday. So I'm coming back regardless. So I'll be there. Okay. So we've got something called the fundamental theorem of calculus. So it's clearly fundamental. There's 2 parts. I call them part who cares. It doesn't really matter to you guys. You don't have to ever name them. This part is the super easy part. Both of them are pretty easy, but students like this. It's just a memorization, kind of something you recognize. And you guys, to kind of introduce it, I mean, you guys know that if you have a square root and you square it, they kind of cancel each other out. If you have a cube and then you cube root it, they cancel each other out. If you add 2 and then subtract 2, they're inverse operations. You just get back to where you started. And so when you do inverse operations, it kind of undoes the other one. And so nothing really happens. And so the key takeaway here is to really focus on that. You guys should know both of those symbols. One of them is the derivative, and one of them is the integral, and they're inverses. Okay, so they're gonna just cancel each other out. Technically, you could go integrate something and then go take the derivative, but it just ends up being a colossal waste of time. And what this rule says is that if you take the derivative of the integral, okay, you'll see there's 2 things here on the integral sign. This guy down here is going to be a number, and that guy up there is going to be a variable or something containing a variable. The answer to this whole problem, this whole question, cover that up. The derivative of the integral, the answer to that is you take whatever the variable is, you go plug it into the function, and that is your answer. It's that easy. It's almost so easy, it's confusing. So let's jump into a couple examples, and I'll talk about the most common questions and stuff. Since you're not really live, I'm going to have to guess what you're asking. So you're given capital F, okay? Capital F of X is this function, and they want you to find the derivative of that function. So we're trying to find the derivative of that function, which is the integral from 0 to x, the square root, cosine t dt. So a couple things to point out at the beginning. That number we don't care about. It might be a 2, it might be a 3, like that. Doesn't matter. You can ignore it. Okay? Now, this is a t. Some of you are like, what's up with that? Well, you can't have an x here and then a function with x's, dx's. That just gets confusing. So they make this the x, and this just becomes some other variable. So they want us to find the derivative of that function. Well, when you do the derivative of the integral, they negate each other. They cancel each other out. So you're looking for that relationship, and then you say, hey, all I have to do is go plug in x wherever the variable is, and I get the square root of cosine of x. And you're done. That's it. Okay, I'll do it again, and we'll talk about when things get weird. And it's not hard, they look different. Okay, again, you're given capital F is this function, and you're supposed to find capital F prime. So you want the derivative of this guy. Okay, so again, you want the derivative of the integral from 3 to x of cosine of t dt. Looks real similar. What's the only difference? That 0 becomes a 3. And what I said right up here is that you can ignore that. This does not change your answer. You still recognize that relationship as inverse, so they undo each other. All you have to do, go plug in your variable, square root, cosine of x. Okay? All right, so let's make it a little bit harder. This is exactly what happens, right? I do notes, and you go into homework, and you're like, what the heck, Carpenter? So look at this guy. They've switched it on you. This guy went from a number to X. This guy went from a number to X. And this guy now is going from X to a number. Okay, if you're keeping up with the videos, we just talked about two properties yesterday. One of them, down at the bottom of yesterday's notes, said, hey, if you want to switch these bounds, go for it. You can switch them. Just make the sign in front opposite. If it's positive, it becomes negative. If it was negative, it becomes positive. So all we have to do to fix this guy is to say, well, hold on. If capital F of X is this, I could rewrite that because I don't like it going from X to 5. I want it to look like my theorem, which says, hey, have the number at the bottom and the X up top. And so I'm going to switch those. I'm going to say, let's go from 5 to X of 3t sine of t dt. And instead of positive, since I switched the bounds, all I have to do is add a negative in there. And now I can answer the question. F prime, the derivative. Find the derivative of this whole thing. Well, the derivative of the integral cancels out. I take my X, I plug it in, and I get 3x sine of X. And don't forget your negative sign in front. Game over. Okay, so that's one thing that they could do to you to switch it up. All right, the last thing that they could do on this FTC part, who cares, is make it a little bit more complicated. My doc cam isn't very clear. Let me zoom in there. You guys can see that says x cubed, right? That's very different than just an x, okay? Right here, this is just an x. So it's just that typical chain rule. You plug it in, and then it's d stuff, right? So that's what this guy says right here. Go plug in g of u, right? Take this guy, go plug it in, but then don't forget to multiply by the derivative of what you plugged in. Okay, so this should look really familiar. This is just like example 1 and 2. We don't care about the 0 there. We want capital F prime. Well, if capital F is this whole thing, I now want the derivative of that whole thing, and the derivative of the integral is the FTC. What does that mean? That means that you should memorize, go take x cubed and plug it in. You get the square root of cosine of x cubed, but then you just have to remember times the derivative of what I plugged in, which is 3x squared. And that's it. That's literally a multiple choice question on the exam. Most common wrong answer, right there. Students remember, oh, I remember derivative of inverse or derivative of integral. It's just the FTC. Just go plug it in. That's true, but you can't forget that chain rule. Technically, you guys, we were doing that the whole time, right? Math is always consistent. When you guys plugged in x here, okay, right here, you plugged it in, you got that. You actually multiplied by the derivative of what you plugged in. But what's the derivative of x? It's just 1. Okay, cool. I'm glad FTC part 2, you'll have me back in the class. I miss you guys. Man, you know me, I can't stand being stuck at home doing nothing. I want to be there with you guys in the good fight. So I will see you on Monday. For all of you who are watching the lessons, I appreciate it. I hope they're helpful. And if you're freaking out about homework and stuff like that, just count on a couple days next week. We'll do some after school tutorials, okay? Or lunchtime or whatever we got to do to get caught up. Take care.